I am Gabriela de la Cruz Sanchez. I am a PhD in linguistics student, and I'll talk about the vowels in Temoaya Otomi. First, I'll introduce the topic, then I'll move to the methodology that was divided into different stages, and I'll present a discussion, and finally, I'll reach the conclusions. I'll also manage one of the sections. Otomi is a group of 22 linguistic varieties that are native to Mexico. They are classified in 9 different groups. The order that they follow is usually SVO. Since this is a project language, we can also identify BO. And the variety that I document in this paper is the Temoaya Otomi variety. This one belongs to the Western Otomi group. This group is made up of 3 varieties: the Temoaya Otomi variety, the San Felipe Progress Otomi, and the San Andres Cuscantitlan Otomi. So across these different varieties of Otomi, we can see that the vowel system has some differences. So I have highlighted the Temoaya Otomi, documented in 1949 by Andrews. We can see that in this variety, we have 9 oral vowels and 3 nasal vowels. And in this, and after this, we can find the Toluca Otomi variety, which are pretty close and could belong to the same group. And we can already identify one difference. So in Temoaya Otomi, we have the schwa, but we don't have a schwa in Toluca Otomi. But they both have 3 nasal vowels, which we can contrast with Santiago Mezquitan Otomi, because this language has just 1 nasal vowel. And then, for instance, in the last row, we can see San Ildefonso Toltepec Otomi, and this variety has 5 nasal vowels. So the purpose of this research is to analyze the vowels and present an updated vowel inventory of the language as currently spoken. And we'll see that modern Temoaya Otomi has a different vowel inventory than they described in 1949. So the first stage of the methodology is I first collected 6 different original anecdotes that go from 5 to 10 minutes and last a total of 30 minutes. All of them come from 2 Otomi Spanish speakers that are in their 60s. It is common nowadays to find bilingual speakers. The elicitation sessions were done virtually, and all the anecdotes were recorded using Zencaster. Then once I had the recordings, I used Ellen to do a broad transcription of the recording. Then these transcriptions were analyzed with Python in order to identify all the possible vowel environments. And I noticed that there are 12 diphthongs in this anecdote. So I listed here the 12 diphthongs that I found. And then I have here in this chart the vowel environment. So we can see all the nasals and plosives and all the consonants that on the language that can precede the vowel A, all the consonants that can follow vowel A are the ones that can precede vowel E, and the ones that can follow vowel E. So when I had a better understanding of the vowels in the language, I elicited 70 words in controlled vowel environments. I exported these words to Pratt for their analysis, and 122 vowel formats were plotted with RStudio to get a first impression of the vowel distribution. So here I have the vowel distribution. So you can see here the formats F1 and the F2. This gave me a better idea of how the vowels behave. So once I had that, I used minimal pairs to contrast and to identify the phonemic vowels. So one example that I have here is 1A and 1B. So we have here Shani, like for hurry up, and then I have Shani for shred, and I have, for example, Badi for no, and Pidi for scare. And so I conclude that we have 2 front vowels, 3 central vowels, and 3 back vowels. From these 3 central vowels, 1 is nasal. So we can say that we have 7 oral vowels in the language and 1 nasal vowel, that is A. I also identify that stress in the language is phonemic and indicates tense. So for example, in number 3, we have PD for scare, but if I say PD, it means he scared him, like BPD, he scared him. But if I change to stress and instead of stressing the second syllable as in 4, I stress this first syllable of PD as in 1. So this is going to be a little bit confusing for the listener. Length in the language is used to contrast contextual meanings such as surprise, disbelief, or affirmation. So here we can see this one consonant vowel, E. I mean, one vowel word, and it says to come. And in number 7, like equam, like I make it longer. So I say come here, right? So and again, we can see that it's just one vowel. It's a one vowel word. So Temoaya Otomi has 7 oral vowels and 1 nasal. All vowels can be nasalized due to co-articulation, but it's an optional allophonic rule governing process. And there are 2 conditions in which we can find the vowels nasalized. The first one is when they are adjacent to a nasal consonant. For example, na, one, na, or ten along the side. So we can see that N is triggering the nasalization of A, while N in number 9 is triggering the nasalization of I. And then another is the rhinoglottophilia. That's another condition. The rhinoglottophilia generalization. So Matisov says that glottal consonants or consonants with glottal features like aspiration can trigger nasalization by themselves without any other nearby nasal consonant. And that's what we can see number 10 to 13. So we can see huh for the yes, and we can see kahni for people. So we can see that there's aspiration here and the glottal consonant. But in the case of the adjective kani, we can see that it's a leafy vegetable, but there is no nasalization of vowel A. The same happens in the number 13. So we can see kati, like keeping. The same happens in the case of you. It occurs when it's close to an aspirated T or glottal, like in 14. So we can see 14. So we can see ton, ton. So we can see that the aspiration of T is triggering the nasalization of U, and then the glottal is triggering the nasalization of the second U for name. Or we can say here in tu, like for harvest or sing, we can see that there's nothing triggering the nasalization of first U, but the glottal in the second syllable is triggering the nasalization of the U and the second syllable. So example number 16 tells us that the nasal cannot be responsible of the nasalization of E in this case, because in the word ndute, carry water, the N consonant is too far away from E, the nasalized E. And if the N were responsible of this nasalization, well, first U should be nasalized before E, which is not the case. So the responsible of the nasalization here seems to be the aspiration of T. So we can conclude that the Temoaya Otomi has 7 oral vowels and 1 nasal vowels. The data also allows us to say that nasalization due to co-articulation is allophonic and occurs when vowels are adjacent to nasal consonants, or in the case of the rhinoglottophilia generalization. Length is a result of contrasting contextual meaning and occur in the stressed syllable. And Temoaya Otomi vowels are Temoaya Otomi words are vowel final, except for Spanish borrowing. That we were able to notice that while analyzing the data. Most vowels, but not all the vowels, such as A, can appear at the beginning of the word or syllable, and some vowels can stand alone and be more than one lexical item, like in the example of E and Iqua we saw. And lexical items made of one syllable that is a consonant, a vowel, are a recurrent pattern in Otomi. And I identified 12 diphthongs that are composed of 2 vowel clusters. So I acknowledge that this work was made possible through the cooperation of many instructors and professors at the University of Arizona and from other university. And here I present references. Thanks.